Well, hello. Welcome to IAEI News Live, and today's discussion and topic is going to be around 110.16 of the National Electrical Code, the arc flash hazard label warning, and it all starts now. All right, well, welcome back to another IAEI News Live session. My name is Thomas Dimitrovich, and we're live, and we're going to be talking about Section 110.16. Today's session is going to kick off a series of programs around the National Electrical Code. I think what I'd love to do on this channel is start to create a living document or a living video series on the National Electrical Code. I chose to start with 110.16. I don't know why. I just chose to start with 110.16. Hey, Nihad El Sharif, good to see you, buddy. Thanks for joining in. And on this IAEI News Live Tuesday afternoon at lunch, 12 o'clock Eastern. All right. First, we talked about the video series. I want to encourage you, please, to subscribe. Hey, William Snyder. Hey, yeah, you gotta love it, buddy. So I'd ask that that if you can, we have our YouTube channel. If you're watching this on YouTube, or if you're watching this on, you like my new glasses, buddy? My readers got to keep them ready. So if you're watching this on LinkedIn, or if you're watching this on Facebook, you got to hop out to the YouTube channel. It's youtube.com/C/IAEI International. So check out our YouTube channel. Get out there. Mr. Felix Sandoval, Mr. Hofkin, Lou Petrucci. I hope I got that right, Lou. Anyway, Bill Snyder, Nihad El Sharif. We got a lot of good dialogue, and today's discussion is going to be, I think, hopefully it's going to be a good discussion around 110.16, which is arc flash labeling and whatnot. We're going to go over some of the history, but don't forget youtube.com/C/IAEI International. Get out there. I know some of you are watching it on YouTube. Subscribe to the channel. Don't forget to subscribe. Also hit those thumbs up. Mr. David Engelhart, I know it, buddy. I counted on you to be here. Also remember, membership has its advantages. Join, get out to IAEI.org, and you'll see a membership link. Encourage you to join the IAEI and get involved with your local chapter or division or your sections. Get a little grasp over how the organization is laid out, and understand that, especially at the local chapter level, we need more people to get involved. We need people who have the motivation, who have the drive to want to change our electrical industry, who wants to leverage the organization from an IEI perspective to meet other people, create those forums to get together, because we learn through working with others. We don't all have the answers. So IAEI, join, find your local chapters, get out there and engage. I also want to make sure it's clear. Anything I say on this channel is my opinion only. I sit on code making panel 2 and 10 for the National Electrical Code, NFPA 78, 1078, and a few other NFPA documents. But my opinions on that I express here are my own. They do not reflect NFPA. They don't reflect IAEI as an organization. These are my opinions. So I'm going to be sharing with you a little bit about what I know about 110.16. There's one more section meeting down in Asheville, North Carolina. The Southern section meeting starts next week. Typically, that Southern section starts on a Sunday evening with a great meet and greet. They have a technical programs Monday, Tuesday, and through Wednesday afternoon. I know Mr. Hofkin will be there. I know all of the leadership and all of the key players from your local southern section to all the different chapters within the southern section will be there. So will Rudy, our CEO. So you're going to want to check out the southern section if you haven't been there. It's not virtual, but I do have plans to try to grow the online and the video and virtual world of bringing some of that technical knowledge online. But nothing can replace being in person, breaking bread, drinking coffee, having breakfast, having dinner with other like-minded individuals in our electrical industry. So please, the online world is great. It's great. It's ready. It's access. You'll get Michael Hopkins, the Vince Delacroces of the world. Vince is with Siemens. You'll get Lou Petrucci, William Snyder, Nihad El Sharif, all the way from Egypt. You'll get a lot of different key individuals who are very knowledgeable, leveraging the chats and all that great stuff. But always great to see people in person. So anyway, Michael, I wish I could be there, buddy. I am heading out to Denver for the IEC convention, which I leave Thursday this week. I get back Saturday, and the NEC cycle has really got me swamped. Panel 2 meetings are coming up. I got to get my work done for the task group work, so I don't know that I'm going to be able to be in the southern section. It'll be the first one I've missed in years. So anyway, let's get on to this program, all right? Because enough chit-chat. Let's get straight into the National Electrical Code. And like I said, I want to create a series. And I'll be reaching out to the Hopkins of the world, possibly the Engelhertz of the world, and the Felixes of the world, and others who can maybe help us understand some of these things we call sections, parts, articles in the National Electrical Code. Today's focus is on 110.16, which is titled the Arc Flash Hazard Warning. And I'm telling you, I'm prepared. I've got all of my code books going back to the very first edition that introduced this section. I've got my reading glasses, my new reading glasses, my spectacles, and I can throw away my notes. Don't need those anymore. And let's get down to talking about 110.16. Okay, so first off, remember, you can go out to the IAEI's website. You can get the analysis of changes, not just the 2020 codebook analysis of changes. You can get the 2017 version analysis of changes or earlier versions. Reach out, and if you don't see an option on the website, reach out to IAEI's send them an email, give the IO a call, the international office a call, and let them know you want to purchase something that's maybe an older version that might just have been or is currently has been adopted in your jurisdiction. The IAEI, this is one of the greatest resources from a code changes perspective, and you'll want to make sure you get those analysis of changes for whatever version that you're working on. And it's great to have a history of them. I've got all of the analysis of change books going back. I can't tell you how far. It's great to have those sitting on your shelf because for two reasons. And what you're going to learn today, you're going to learn how to research the changes in the National Electrical Code. So I don't want to just say, here's what happened. I want to teach you how to fish. I want to teach you how to go out to the NFPA's website, and I want you to understand how you can do your own homework, right? This is what this is all about. This is not just me going this way. This could be you doing your own homework on any section of the code that you find either of interest to you personally or that's causing you some grief out in the field that you want to help people understand why the code changed. So these analysis of changes books do that very well. They save you the time and money and research to doing it yourself. They are created by the IAEI's members who are on each of the code making panels. Huge value for you. So they'll save you time, all that great stuff. Get your copy. Arc Flash. It is the light, the heat, the light, the heat, the sound, the gases. Everything that goes into an unintended rapid disassembly in the field is happening right here, okay? This is something that our electrical industry unfortunately lives with. And I can tell you, I can have my opinion that we don't have to live with this, because there are ways to avoid this, to reduce the occurrence of these events. We don't have to necessarily live with these events because we can design around them. But this change was driven out of events like that. Now, if I look back at the history of 110.16, which we're going to do together, the original intent of the submitter was to create an arc flash instant label equipment with incident energy. What was eventually agreed upon in the first edition, which I'm not going to tell you the year, the first edition of the code that required 110.16 was the standard arc flash hazard label that just basically says you can get hurt. They started off with more of what I would call a 70E label. Calories per centimeter squared is how we measure the heat, and the distance, the working distance, and the arc flash boundary. And we're going to talk about 70E. I've got my version of 70E. I want you to get your version of 70E because we're going to be walking through that together. All right, so let's take a look. So as I move into this, the first introduction was the 2002 version. So here's what I'm going to do. I'm going to bring up a window, and I'm going to go to nfpa.org/70. And I'm teaching you how to fish here, right, Michael? Teach a man to fish and you feed him forever. Absolutely. So what I'm going to teach you now is, here's how you find the history around all of this. Your first step is to figure out what version of the code it went into. How do I do that if I don't have old versions of the code? Hey, Bill Snyder, you better watch this later, buddy. You better, buddy. So here's what you do. You can view the earlier versions of the National Electrical Code for free right from their website. You come down to where it says Select Edition, and if you're looking at, for example, 110.16, a couple things you got to remember, especially if you're going to search any documents. There was a point in time when it wasn't a 110.16, it was a 110-16. These are those little changes that can hook you and get you going down the wrong direction. But remember, there was a change in the National Electrical Code from a dash to a dot, and we'll figure out. We'll talk about when that occurred. Now, I know that this went into the 2002 version, but if I didn't realize that, I could go back to, say, the 1999 version, hit a Select Edition, and then you'll see free access. And well, actually, you don't even have to do that. You go free access and then select the edition. So let's go back to 1999 and let's take a look and view it. Proceed to free access. I agree. And then you will just go down through the document. You can look at the table of contents. You can go to 110 and just look for your 110.16. So there's 110.14, which is your terminations, and 110.16 is not there. So you know it wasn't the 1999 version, and I'm telling you, if you go to the 2002 version of the NEC, it will be there. So just save you a little time. Now, we're going to select the 2002 edition down the bottom, scroll down a little bit on this website. And let's just take a look at what we see. We have any tentative interim amendments that were made to that year. We've got erratas. Yes, some mistakes can be made. No one is infallible except the big guy. Not this big guy. Then you have archived revision information. This is your little pot of gold. Remember, back in the day, we called it an ROP, report on proposals, and an ROC, report on comments. This is the document that you can use to help understand what motivated the change in any section of the National Electrical Code. So we're going to view the report on proposals. And it's relatively quick. It's a PDF document, so it's an Adobe Acrobat file. I'm going to search. Now remember, I know because I've got my code book. I got my 2002 version of the NEC. Never throw these away. I'm just saying you paid good money for them. And even if they're not applicable, don't think that you'll never use them. Keep them on your bookshelf. You know what's nice about these books? That you don't have to feed them. There's no general maintenance. You don't have to change the oil every so often. You don't have to change the tires or change the brakes. And they take up minimal space. And I know you're going to say, boy, I wish they were this big like they used to be back in the day. But they are 8.5 by 11. But again, they don't eat. They don't need fed. They do need read. So 110.16, and it wasn't a dot, or actually it was a dot. 110.16 was an earlier version. So in the 2002 version, they were dots. All right, so let's do a search. 110.16. 110-16. Oh, I don't have my earlier version. This is what, 2002? I'd need my 1999 code. Let's take a look. I'm going to take a look at my 99 code because it could be that the 2002 version is the version that got rid of that dash. I'm going to just check it. 99. I'm going to go back to the 1987. Wait, no, 1993. Hold on. No, this is the 2002. I got to go back to the 99 version. I had it right the first time. 2002. I'm going to go back to the 99 version of the National Electrical Code real quick. Yes. All right. So, we just learned something. In the 99 code, we had dashes. It was 110 dash whatever, or 210-8. It was the 2002 version of the NEC that went to the dots. So, thing to remember. So for us to find this in the ROPs, remember, the proposals would have been made against an earlier version. So the section numbers are 110.dash, 110-16. I got to make this down, and let's do this. I'm going to get rid of this over here. How do I get rid of that? I don't know how to get rid of that. Oh, that's okay. Here's what we got. 110-16. And we have an accept in principle. That was the panel action. I want to go to the proposal number. All right, so here is the new section, accept in principle. That was the action back in the day. That's what we did. The Technical Correlating Committee directs the panel to change residential to dwelling to comply with current word. So here's just to give you a little understanding of the process. The code panel will have reviewed the public inputs, made any of the necessary changes. It would have gone up to the Correlating Committee. The Correlating Committee looks at it, makes any little tweaks, and then says, all right, we're going to direct you to make some changes. Ray Jones, Electrical Safety Consulting Services. Ray Jones wanted, what did Ray Jones want? Add the following new section. He wanted to call it flash protection. For other than residential occupancy, switchboards, panel boards, load centers, motor control centers shall be marked in the field to indicate the incident energy in calories per square centimeter for a worker at a distance of 18 inches. Now, you got to understand what was going on in the industry. This is the 2002 version of the National Electrical Code. One of the key things, one of the key industry activities that were going on was research around incident energy. And if you look at what Mr. Jones was saying, a significant number of electricians are being seriously burned and often killed from accidental electrical flash while working equipment hot. Now, statistics. Remember, behind a lot of the information, a lot of the code changes that we have, there are statistics. We could, I don't want to debate how many people need to get hurt or killed. But when we understand the hazards, our goal should be to try to help mitigate those. Now, I'm going to point you to a great resource in 70E. I know you have the 2021 version of 70E. I know you are going to go online and purchase your version of 2021 70E if you don't have it, because it's a very important thing to have if you work in the electrical industry. Informative Annex K will point you to a great resource. Informative Annex K, and it comes after J and before L. Informative Annex K is general categories of electrical hazards. What I like about this is it speaks to some of the statistics around incident energy and shock. Unfortunately, 98% of fatal occupational injuries are electric shock injuries. Arc flash is, it says in here, in the recently issued 29 CFR subpart 5, OSHA identified 99 injuries that involve burns from arcs from energized equipment, faults, or failures. There we go. Resulting in 21 fatalities and 94 hospitalized injuries for the period of January 91 through 1998. So when we think about risk, Risk is, and we're going to be talking about this because this is important to understanding the beginnings of 110.16. Risk is about likelihood and severity. That video that I showed you spoke to the severity. The statistics speak to the likelihood. So I'm going to be referencing 70E various times throughout our 1 hour discussion today. So this was the impetus around creating this, and you'll notice it says that there was an IEEE paper from Dowdy, Neal, Floyd, predicting incident energy to better manage the electrical arc hazard on 600-volt power distribution systems. Now, and this was at the PCIC, Petroleum and Chemical Industry Conference, and it's commonly referred to as the PCIC conference. So what you had going on in this time frame, there was research being done. We were right on the edge. This is the 2002 version of the National Electrical Code when it was first introduced. IEEE 1584 is the document that we use to calculate incident energy. So you got to think about the mind of Ray Jones, Lanny Floyd, all of the other people who were heavily involved in the electrical industry. They know what's going on over at PCIC. They know IEEE 1584 is right around the corner. And I'll bet you, if I'm a betting man, that if I go to the IEEE 1584 2002 version of that document, which I believe I have a copy of. There it is, IEEE Standard 1584 2002. I'm going to do a quick search for Jones. I'm going out on a limb. Yes, Ray Jones was a part of the participants for developing IEEE 1584. So here you have a gentleman who's sitting on the committee. He knows we're creating this document, and he's saying, look, we need to start requiring the labeling of equipment. Hence why Mr. Jones said, look, we need to have this as a requirement. So what did the panel do? Let me show you something. Let's take a look at what did the panel agree to. The panel action was accept in principle 110.16 switchboards, panel boards, and motor control centers installed in other than residential occupancies shall be marked in the field to indicate the incident energy in calories per square meter for a worker at a distance of 18 inches. This would have been all switchboards, all panel boards, and motor control centers in other than residential occupancies. And they referenced 70E 2000 for the methods, because here's what's here. Think about it. This is what's going on. You've got IEEE papers that are doing some research. They're coming up with equations. They're getting more and more with their head wrapped around how to calculate these things called arcing currents and calories per centimeter squared. And they're being introduced into 70E, and they're putting the equations in there. And the panel statement was the term load center was removed since it did not appear in Article 384, and the fine print note was added to give further direction to the user. 13 eligible to vote, 11 affirmative, 1 negative, and 1 not returned. And the negative vote came from NEMA, John Minnick. Many of you probably know his name. So it looks like, remember, this is early. This is early in the days of what we know about incident energy. And it looks to me like he's basically saying, look, it's there are various ways to do this. There are various equations. And I think it's just early in the process to start making a requirement. If I were to summarize what his issue was, that's what I would say. So now, to fully understand the process and why a change was made, you can't just look at the ROP. What we do know is that in the proposal phase is not what we see in the NEC. 110.16 doesn't say what we just read. So now you've got to go to the ROC, Report on Comments. I'm going to click the view. And now we get the report on comments. So let's take a look. And we're looking for what? We're looking for 110-16. Control F, 110-16. Looky here. 110-16, we had a bunch of public, just like anything. When something is new, it's never been introduced, you're going to have a lot of people coming out of the woodwork and saying, I don't like it, or yeah, I like it. So we had a reject. This person wanted to remove incident energy calories per centimeter squared and just say level of personal protective equipment and prevent many burn injuries. Substantiation. This will prevent many burn injuries. Remember, substantiation is 99% of this to get in something you want in the National Electrical Code. There was another one, American Chemistry Council, just wanted to say put the level of personnel protection. We had, I don't know what Mogo Enterprises in, 18 inches based on field conditions. So what's interesting is read through the proposals that even failed and read through their substantiations. Sometimes they're good, sometimes they're bad. Sometimes they're accurate, sometimes they're way off base. But it helps you understand the dialogue at the time this was going in. All of the different perspectives and how I usually try to help people understand this. Try not to put your opinions into it. Read and how you portray it is one group was saying this, another group was saying that. And then you look at what was finally agreed upon. Not that this group was right or that group was wrong. It's just that these are the opinions of those who found it of interest enough for them to comment on these requirements. Fred Hartwell wanted to reject the proposal and introduced a lot of Fred Hartwell's out of Massachusetts. We had Noel Williams wanting to reject the requirements, remove the requirements. Michael Callanan, IBEW, wanted to remove the requirements. No, I'm sorry. No, accept this proposal in principle, revise it to read 110.16, because this was an accept in principle. 110.16 flash protection, switchboards, panel boards, and motor control centers having a short circuit current rating in excess of 20,000 amps shall be marked with the following label: warning, electrical arc flash hazard, serious injury or death, use appropriate level of personal protective equipment. So what Michael was going after, what the IBEW was promoting, was saying, look, if it is greater than 22,000 amp short circuit current rating, meaning you've got a lot of available fault current at that service entrance equipment, or no, at not service entrance equipment, just at a switchboard, panel board, or motor control center. So you have a lot of you have a significant amount of fault current. They were looking at a label that just said warning, electrical arc flash hazard. And you can read through their substantiation, and you can look at the panel action. The panel action, which is behind my head, which I can fix. Watch. Here's how we fix stuff like that. Panel action was to create a 110.16 flash protection. Switchboards, panel boards, industrial control panels, and motor control centers in other than dwelling occupancies that are likely to require examination, adjustment, servicing, or maintenance while energized shall be field marked to warn qualified persons of potential electric arc flash hazards. The marking shall be located so as to be clearly visible to qualified persons before examination, adjustment, servicing, or maintenance of the equipment. And they referenced 2 fine print notes. Remember, they called them fine print notes back in the day. They weren't informational notes. And this is their panel statement. So this is a statement that's typically voted on by the panel. The panel concludes that requirements for warning of potential electrical hazards are within the purpose of the NEC and agrees with the need to warn qualified persons of the potential of arc flash hazards in non-dwelling locations. However, the panel wants to emphasize the importance of de-energization and implementation of safe work practices outlined in 70E, in addition to recommending the use of appropriate personal protective equipment. The panel believes that the revised wording meets the intent of the submitter. 12 affirmative, 1 abstention, and there are some comments on affirmative. Floyd. Now, if you want to know who Floyd was, what you do is you go to your book and you go to code making panel. This is what section? 110. This will be code making panel 1. Code making panel 1 has jurisdiction over Article 110. Floyd was Lanny Floyd DuPont. I didn't know he was on there. And he represented the Institute of Electrical and Electronics Engineers. So Lanny was the IEEE rep. And remember, Lanny Floyd is also heavily involved with IEEE 1584 and 70E. And I don't have that version of 70E to see if he was on it. But Lanny is one of those individuals in the industry, just an electrical engineer that worked for DuPont, and he's still around, and he's still heavily involved. Hasn't decided to set down any reins. He's very active in electrical safety. Great guy. So he commented on the affirmative, stating 1-152 will also serve to stimulate innovation and advancements in product and system designs that reduce or mitigate the hazard. Past 5 years, the major U.S. manufacturers of medium voltage switchgear have introduced advancements in designs listed as arc resistant, increasing market demands and to address the hazards through similar technology advancements will reduce the equipment installations needing warning labels as required by 110-16. So Lanny recognizes that when you have code requirements like this, historically significant, remember the arc flash, the presence of code requirements around incident energy. There's a lot of information in here around shock, and we continue to grow shock protection, whether it be barriers or GFCIs or working space, things of that nature. From an arc flash perspective, relatively very little exists in the National Electrical Code. You've got 1971 introduced ground fault protection of equipment to address incident energy issues at service equipment. You've got this labeling requirement that was introduced in the 2002 version. We know that 24087, 24067 And then there are some changes in and around the 6 disconnect rules in the 2020 version of the National Electrical Code. So there's a lot of different changes that indirectly impact, but this one started, I think, plays a significant role in the history of arc flash incident energy requirements in the National Electrical Code. Although be it only a label, it played a significant role in the development of the NEC with regard to its partnership with 70E, part of the trilogy. Okay, so now we get a better picture. So now if we looked at the 2002 version of the NEC, and we go to 110.16, and I just lost my sticky. 110.16. It says switchboards, panel boards, industrial control panels, and motor control centers that are in other than dwelling occupancies and are likely to require examination, adjustment, servicing, or maintenance while energized. That's a significant piece of the puzzle. Remember, it says are likely to require examination, adjustment, servicing, or maintenance while energized. If something can be shown that is not likely to require servicing while energized, it would not have to be marked to warn the qualified person of a potential electrical arc flash hazard. So, and that's solely on the burden of the inspector. Think about it. There's nothing in the code that defines likely to require energized, likely to require to be examined or adjusted while energized. This is a relationship between the installation, the engineer, the owner, and the inspector to determine what is and isn't likely. But in reality, we're talking about a very simple, and I say a very simple label, we're talking about a very simple label change, which is the one you see farthest from me, an electric arc flash hazard. Now, in this language, it also says the marking shall be located so as to be clearly visible to qualified persons before examination, adjustment, servicing, or maintenance of the equipment. But it also says shall be field marked to warn the qualified person of the potential electric arc flash hazard. Now, if you think about it, it's field marked. That's a very generic label over there. And what the initial language read, that it has to be field marked. That means that I, as a manufacturer, would not be able to put this label on before it left the factory. And this presented a challenge because in many cases, we will put that label, the manufacturer, whether it be Schneider, GE, Siemens, Eaton, whoever else makes equipment of any type that would fall under the requirement 110.16, which would be switchboards, panel boards, and industrial control panels. Quite often, this label is put on at the factory. But think about what the language says. The language said field marked to warn. So field marked. And there were instances where I would get phone calls where the inspector would require them to put another label on or remove that label and replace that label. Most did not do that. Most just said, look, it's labeled, it meets the intent. But then they went back to the National Electrical Code and said, look, we got to fix this. So if you look at some of the history of the changes so that's the 2002 version of the NEC. I think we're through with that version. We'll throw that one over there. Now we're going to get the 2005 version of the NEC. A couple things. You see how I labeled it here? I put my name there. I also put my name there because it's harder to erase when it's on the spine. I was very possessive about my code books. So now let's take a look in the 2005. What they did was they added in 110.16, I just want to make sure that's the only change. They added meter socket enclosures. And if you wanted to see that change, we could go through the same exact process. And I'll show you that one. We'll do that for giggles. Go to NFPA 70. Scroll down and go to current and prior editions. And we're on the 2005 version. So you select your 2005 version and hit select edition. That will change everything down below. Don't forget to hit select edition. Scroll down to where you see archived revision information, and you'll see report on proposals. Now this one had a part 1 and part 2. That means there are a lot of public inputs or a lot of proposals made. Because this is in 110, good chance of it being in part 1. Click on view, and then we're going to search for 110.16. It's no longer a dash. Why? We just learned that. Oh, look at this. There we go. How do I get rid of this? How do I get rid of that? But anyway, this says the submitter was James T. Dollard, Jr., IBW Local 98. And look what he wanted to add, meter socket enclosures. So Mr. Dollard got what he wanted out of that change. And it says the intent of this section of the NEC, this was his substantiation. The meter socket enclosures in some cases contain service conductors. Switchboards, panel boards, industrial control, meter socket enclosures, and motor control centers that are in other than dwelling. All right, so this is not just service equipment, but he's pointing out that meter socket enclosures are on the service equipment, that although the meter socket enclosures may contain service, blah, 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 the motion was an accept, and the panel statement said this, the panel refers the submitter to panel proposal 1-172A. The panel does not necessarily agree with all of the submitter's substantiation. All right, so let's go to log CP102. So we're going to type in CP102. And we're going to go down because we have to find is the committee public input, CP102. So let's keep searching. And you'll notice that they are, Daryl Jones, Bidding Electric, wanted to make a recommendation. And then they referenced, the panel statement was pointing them over to CP102. Kim Fraze, panel refers the submitter to CP102. The panel submits the CP102, meets the intent of the submitter, CP102. We got to find CP102. Uh-oh, what's this? Panel refers to CP102. Meets the intent of the submitter. Meets the intent of the submitter. Here we go. All right, so now we found CP102. This is what I love about being live. I didn't prepare any of this. All right, so CP102 was an accept. And what does it say? So this was a code making panel 1, revised 110.16 to read as follows. Barrios. Oh, wow. This is Barrios. You know, Barrios is Barrios. Let's take a look. Panel 1 membership. Louis, I'll bet you it was Louis Barrios. Yes, Louis Barrios from Shell, representing the American Chemistry Council. Louis is currently the chair of NFPA 70E. What a quinky dank. So this was an accept, affirmative 7, 4 negatives, and we're going to look at what they did. Substantiation. What did they did? Arc flash, switchboards, panel boards, closure, motor control centers for other require examination. That all seems the same. Oh, look at this. Calories per centimeter squared. Shall be field marked with a label indicating the incident energy available or the rating of needed protective clothing in calories per square centimeter. to warn qualified. So look, it's cropping up again to require calories per centimeter squared, not just a generic label. So you see the intent from the get-go was to create a label that says calories per centimeter squared. The panel kept pushing back on that. This is the first draft. This is the proposals. Let's take a look and see what happened in the comments phase. So there's a report on comments. We're going to hit view. I love this stuff. Don't you love it? Come on, you got to love it. And we're going to do what again? We're going to do a control F for find, and we're going to do a 110.16 because it's no longer a dash. And there it is, 110.16, accept in principle. The proposal 1-73 should be accepted. And that was accept in principle, 1-173. Let's go back to the proposals. 1-173. Let's look at 1-173. This is how you research. I'm teaching you to fish. 1-173. So we need a 1 dash. Here it is. Russ LeBlanc. Switchboards, panel control centers are other than dwelling occupancies, remainder to stay the same. So he did not want to change and put the calories per centimeter squared. Ray Jones was saying 173 should be accepted. The proposal identifies the weakness in the language contained that should be corrected. The substantiation offered by the submitter is persuasive. The proposal should be accepted. Remember, Ray was the one who started this. Proposal 1 should be rejected. 1-178. Let's take a look at that one. Proposal 1-178 should be rejected. 178 was the one shall be available short circuit current, the flash protection boundary, the level of incident energy. So this is going back to what Ray wanted to do, and he's saying to reject it. Why is that? The proposal seeks to establish a requirement in the NEC to define a work practice to determine certain system characteristics. As indicated by Mr. Minnick, the NEC is an installation code. Oh, CMP1 does not necessarily agree with all of the CMP1 recommendation and substantiation. All right, so that was an accept. So it looks like they went back to the original language. And if I look at 110.16 in this version of the code, I see the meter sockets, and it says, still says field marked. So the only change that they made in the 2005 version of the NEC, that would be the National Electrical Code, was to add the meter sockets, and they updated the 70E version year. Now, 2008, we're done with that one. 2008. Get your version of the 2008 version. And look at this. That's got the IAEI symbol on it. That's a good one. All right. 110.16 looks like the only change they made was in the beginning of the section. They said they added the words electrical equipment such as. And I'm sure if I go back, and you can find this your own way, go back to the 70 and take a look at all the dialogue in the public, in the report on proposals and the report on comments. I'm sure you will find a lot of dialogue around 110.16. Now, I will note that 110.16 as part of the 2008 version says field marked to warn the qualified person. So the pain point of equipment being shipped with that label or not being shipped with the label, but the label included in the box, that you know where that goes, in the dumpster. So the pain point has not yet been reached, but I'm telling you, it's brewing. There's a storm of brewing. Now, 2000, and that's the only change in the 2008. We're done with that one. On to the next one. 2011. This is when Tom decided to get tabs. This is like the only, nope. this version and the next version, I fell in love with tabs. I have no longer a love of tabs. They are just too time consuming for me to put on. In any case, let's take a look at what we did in the 2011 version of the NEC. We changed the title. What was the title before? We're not done with this one. What was the title? 110.16 was titled Flash Protection. So 110.16 up until the 2011 version was not what we know it today. It was flash protection, and in the 11 version, it went to arc flash hazard warning. And that's what we live with today. Arc flash hazard warning. They also changed dwelling occupancies to dwelling units. So we got rid of the word occupancies and made it a dwelling unit. And then we changed the version of 70E from 2004 to 2009. So the 2011 version, that's all that changed. Everything else stays the same. We're just saying now it's an arc flash hazard warning label, and it's not a dwelling occupancy, it's a dwelling unit. That's just in line with what we call dwelling units. All right, so that was the only change in the 2011. Oh, and the fine print notes no longer exist in the 2011. If you remember those code changes from IAEI meeting to IAEI meeting to IAEI meeting, we talked about the informational notes, the INs, and then the FPNs. And then there was a time period where we still called them fine print notes, and we couldn't get off of the fine print note. Just like some people still can't get off of report on proposals or report on comments, or a proposal versus a comment, as opposed to public inputs, public comments. So fine print notes was bye-bye in the 2011. And remember, 2002 was when we said goodbye to the dash and went to the dots. 2011 is when we went from the FPNs to the INs, and they obviously updated the 70E version number, and then we're done with this puppy. On to the next one. 2014. What a year. The year of still maintaining my tabs. But I'm telling you, at this point in my career, the tabs were getting frustrating. They are much more bent. They're bent. Some of them tore the pages. And it took me a long time to put them on. I think I put this one on in a plane. All right. 2014. Let's talk about the 14 code. It still has the same title. We added switchgear. I don't know, it took us how many cycles to realize we don't have to label switchgear. We were labeling them already, right? It's just a hazard warning label. They're like candy, just hand them out. And this was the year. This was the breaking point. It was 2014 that said, look, why do we have to scrape these labels off that the factories keep putting on? Why can't we just let them put it on in the factory? And now you have the permission to do that. So now we require it, or we require it, but it's permitted to be put on in the factory. So field or factory marked. And also, we put a reference to 110.21b. 110.21 also changed in this version of the National Electrical Code. What is 110.21? Marking. So 110.21 has manufacturer's markings, field applied hazard markings. And so now we have in 110.21 two helpful pieces of information to say, look, if it's manufacturer's markings, the name, the trademark, or other descriptives by which the organization, blah, 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 other markings that indicate voltage current, the marking or label shall be sufficient durability to withstand the environment involved. So if I'm a manufacturer and I put that label on, I need to make sure I meet 110.21a. If the inspector, the installer, the contractor, the owner, whomever puts a field marking a field applied hazard mark, there's a whole set of requirements and references to ANSI Z 535, product safety signs and labels, talks about adequately warn the hazards, talks about permanently affixed to the equipment and durable and all that jazz. Robert from Omaha, fine print note to electricians are notes in tiny writing. That's why I need these. So you had a couple changes that are related. 110.21, 110.16. You can go to the ROPs and the ROCs and see why these changes, what the arguments were for and against this change. And we updated the version of 70E, and then some informational note number 1, a guidance such as an arc flash labeling. So they just added some clarity there. So we said that these arc flash hazard warnings have to meet the requirements in 110.21b, which is field applied hazard markings. But really, they should have said just 110.21. Think about it. And I don't know if we fix that later, but we're going to find out. But it says arc flash hazard, the markings shall meet the requirements in 110.21b and shall be located so as to clearly be visible to qualified persons, blah, blah, blah. So they put the reference in the 110.21b, which is the field applied hazard markings, but they should have also put the reference to 110.21a if the manufacturer puts them on. We'll see if that changed. Do you know why? Because we're going to grab the 17. And I'm going to leave this one open because I just noticed that. All right, 17, $110, 17. Remember what happened in 17, and it still has the B. In fact, I'm going to go to the 20 code because this is an interesting one. 110.16, 110.14, 110.16 in the 20 code still says 110.21b. I don't know about you, but I think that should be just 110.21 because why? It says the marking shall meet the requirements in 110.21b. It should be 110.21 because what if the manufacturer puts the marking on? I don't have to follow 110.21, eh? Only if you do the field apply. That needs to be fixed. We got to see. Anyway. This is why we do this. This is how changes happen when you're walking through it like this. All right, so 110.16. Now we're going to go to the 17 version of the code, and this is the one that added A and B. Electrical equipment such as switchboards. B is the service equipment. So 17 was a historical. We went from this to this. So not from this. You still need to label it with this. But in the 17 code, we introduced the nominal system voltage. You have to put in nominal system voltage, available fault current at the service over current protected devices, the clear time of service over current protected devices based on the available fault current at the service equipment, and then the date the label was applied. And this is what your label will look like. Now, there's a few informational notes. There's an exception. Service equipment labeling shall not be required if an arc flash label is applied in accordance with acceptable industry practice. Which one? What's that one? That is this label. This is the 70E label. And if we go to 70E, oops, caramba. I can't believe I did. Anyway, 110, here we go, 110.5. Let's talk about hierarchy of risk control. Another thing that this answers. 110.5H is the risk assessment procedures. 5 is the hierarchy of risk control methods. 4 is awareness. That's what these labels do, raise awareness. 110.5. I'm looking for my labels. It's in 130, I believe. 130.5. All right, your equipment labeling, 130.5H says nominal system voltage, arc flash boundary, at least one of the following: an available incident energy, which is available incident energy. You got your arc flash boundary, you got your incident energy, you have your system voltage, arc flash boundary, nominal system voltage, at least one of the following: available incident energy and the corresponding working distance. So I have a 2.7 calories per centimeter squared. Where's my working distance? I don't have a working distance. Oh, yes, arc flash. That's the arc flash protection boundary. I'm missing a working distance on this label. That would not meet, or no, required PPE. Minimum arc rating of clothing, site-specific level of PPE. So there's your required PPE. So this is a little bit of a, it's Sidewinder electrical contractors. That's why. I think I have another label here that we could possibly use. Yeah, here's a, I like this label a little bit better. I'm going to put this in the slide deck. So hold on one second. New, Control V. All right, so I like this one a little bit better. This gives you your arc flash protection boundary, your incident energy, and your working distance. That is what's required in 70E. So 70E tells us for equipment labeling, I need to have the nominal system voltage, arc flash boundary, at least one of the following. You have to have the incident energy and corresponding working distance. There's my working distance. There's my incident energy. And that helps me understand how to dress. And then I also, and it says, and then minimum arc rating of clothing or site-specific level PPE. So and I also have to have my arc flash boundary, which this arc flash protection boundary is 16 inches, and my working distance. So I have my arc flash boundary, I have my incident energy, and I have my working distance, and I have my voltage. That is what's required by this. The date is not required by 70E. Now, the way this exception is written in the 17 code, it says service equipment labeling shall not be required if an arc flash label is applied in accordance with the acceptable industry practice. So 70E does not require a date. If you get a label like this that doesn't have a date, it doesn't violate the National Electrical Code. The Electrical Code says in B that you have to have the voltage, the available fault current, the clearing time, and the date. But the exception says I don't have to do that if I follow an industry recognized practice, which is 70E, and 70E does not require the date, although many of us put the date on. Why would you not put the date? That's a good question. What if the only argument I've heard on not putting the date is, what if nothing's changed in my facility and all of my tags are January 1st, 2017. Here I am 5 years later, and the incident energy is exactly the same. I have to go and scrape this off and put a new one on for what? Because of that date. And I would say just put a sticker over top of that has the new date. Anyway, there are ways around that, but it's not required in 70E. But they did put these requirements. So this is one method. You can put the voltage, available fault current, and that is the available fault current at the service. It's not the maximum available fault current. It's the available fault current, and this is in the 17. Remember, we still did not have the definition of available fault current. Let's just double check. A, B, C, D, E, F. Fault current is not defined. Available fault current is not defined. And if you look at 110.24, 110.21, nope. 110.24, I thought it was, yeah. 110.24 is field marking. Service equipment at other than dwelling units should legibly marked in the field with the maximum available fault current. 110.16 doesn't say maximum available fault current. It says available fault current. Why? Because when you're going to do an incident energy analysis, you're not worried about the maximum. Sometimes the minimum will give you the higher incident energy. So they had that discussion at panel 1. I remember it distinctively. And they said we can't put maximum available fault current. We have to put just available fault current, and it will be the actual current at the service, at this equipment, at the service equipment. And the service equipment is where this label is required. In other than dwelling units, in addition to the requirements in A permanent label shall be field or factory applied to service equipment rated 1200 amps or more, and the label shall meet the requirements of 110.21b and contain the following information: nominal system voltage, available fault current, blah, 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 blah. And there's 3 informational notes talking about 70E and Z535 and acceptable industry practices from labeling. All right, so that was the big change in the 17. That was huge change in 17, and it prompted questions. It prompted a discussion. What was the discussion? We had a little bit of the discussion. Available fault current was a piece of the discussion points at the panel. And why is that? Because they realized that, look, the available fault current, it's not the maximum available fault current, it's an actual available fault current. And then who is going to be putting these labels on? If I look at, see, that's the 17. I'm going to grab the 2020 version just to see where we're at today, 110.16. Sir, and other than dwelling units, in addition, permanent labels shall be filled service rated 1200 amps, meet the requirements of one and follow that information. So it doesn't say a qualified person should create it. It just simply says you need to put that on. The 6 disconnect rule. What happens if I am, if this is my equipment up here and I have a main overcurrent device, well, the clearing time is easy to find out. But if I don't have that, and I'm doing a 6 disconnect rule, I could have up to 6 different clearing times. Does that make sense? And then the discussion was, wait a second, who's going to use this? And remember, that information that happened in the 17 code is very relative to table 130.7 Charlie 15A, the arc flash PPE category for alternating current systems. This is the table method. And if you think about what is the table method, if you're familiar with 70E, and you go to table 130.7 Charlie 15A, it says panel boards or other equipment rated greater than 240 volts and up to 600 volts. It's a table. So it's all different types of equipment. And it says for panel boards from 240 to 600, these are the information you need to know. You need to know what's the maximum available fault current. 25,000 amps. Well, that doesn't quite match up with this code. Remember, we weren't talking maximum. We were talking available fault current, not maximum available fault current. So this table requires a maximum available fault current. And then it has a clearing time, a maximum of a 0.03 second clearing time, 2-cycle clearing time for that overcurrent protective device. And then it has an 18-inch minimum working distance. And from that, if you meet those parameters, you can determine how to dress. Well, I could look at this table, and if I'm working on that equipment, my clearing time of each of those overcurrent protective devices, if I'm in that equipment, when I label that equipment, that has nothing to do with how I'm going to dress. Why? Because the incident energy in that equipment is not based upon or determined by those overcurrent protective devices. The incident energy in that piece of equipment is determined by the overcurrent device on the primary side of that utility transformer, which is probably not going to open. I do a 2-second time delay, 2-second delay clearing time on my overcurrent protection, and that would put that into a double or triple digit incident energy, regardless of what you label this. So I would always tell people in the 17 or the 20 code, don't do this. I mean, that's an easy way out to say, I'm going to put the clearing time and I'm going to put the available fault current, but what you really should do is follow 70E and create a label in accordance with 70E, find a qualified person to do that for you and label that equipment, because then that individual is going to be using tools like IEEE 1584 and others to calculate the incident energy in that equipment. And it will be done, hopefully, correctly if you have a good qualified person doing that. But the 110.16 is a good example of the journey that a code change makes throughout the process to arrive at something that eventually gets to where it should be, and it's still not there. I know in the 2023 cycle, they're currently working on language to help clarify the requirements, and it will continue to get attention moving forward, as I'm sure you will be following it. All right. I think that puts me 13 minutes over my 1 hour time. That is 110.16. I showed you how to find the information yourself. It took us a little extra time. I wasn't planning on going into detail, but I think hopefully that will help you moving forward. I helped you understand a little bit about how it relates to 70E. And we went through each year up to the 2023 cycle or the 2020 code. And the 2020 code 110.16. 110.16. Oh, and 110.16b, service equipment. They said in other than dwelling units, in addition to the requirements in A, well, they referenced back up to A. That was the only change, and the date. So the 2020 code didn't see much change in that section. Hopefully, you get a little better of an understanding around why we do what we do and why 110.16 is there and what it requires. Don't forget to subscribe. Please subscribe to the IAEI News channel on YouTube. Hopefully you will get something out of the material that we're putting there. And this is going to be the first of many little videos on each section of the National Electrical Code. Thanks for watching. Thanks for doing what you do for the electrical industry and for electrical safety. Remember to stay safe. Please stay healthy. Thank you, Michael Hofkin, Nikola Tesla, and Robert from Omaha, everybody who stuck in there with me. All right, I'm going to sign off. I got to get to work. Take care, stay safe, God bless, and please stay healthy. Stay out of trouble, too. Goes to you, Michael.